.6 is homogeneous systems, and I said earlier in 2.4 it's just the exact same thing but with zeros on the other side. So they're really easy to solve because either your solution's going to be all zeros or it's going to be infinitely many solutions. So, for example, if we wanted to solve this is a non-homogeneous system. Okay, so we're going to solve the non-homogeneous system first. 2x plus y minus 5z equals 4. 3x minus 3y plus 6z equals 12. Okay, so it's a non-homogeneous system because it doesn't have zeros on the other side. If we were to solve this, so I'm just going to give you the row reduction. So if we were to solve this, this is what we end up with for the row reduction. So what's our solution? This is x, y, z. So x minus z equals 8 over 3. Y minus 3z equals minus 4 over 3. We're going to call that zt. So we get x equals 8 over 3 plus t. Y equals minus 4 over 3 plus 3t, and z is t. So my question is, what if this were the homogeneous system? How does the solution change? Oops. Oops. Zeros. Those are zeros, right? So everything else is the same, but I change it to zeros. How does the solution change? So these would be zeros. So here, these would be zeros. And that's because any plane that ends at 0 has 0 as one of the points, right? So our solution would then be just t, 1, 3, 1. Because the point it goes through is 0, 0, 0. So if you solved it. All right. So when we have a solution, we call this so x equals xp plus t times xh. So this is like a common notation that they use for things. So what does the p and the h stand for? The h you might be able to guess. Homogeneous. It's the solution to the homogeneous system. P is the point, but it actually stands for particular solution. So it's like one possible solution to the system. Yeah, I know. Point. Just remember it's point. Doesn't really matter, right? So this is the particular solution. Particular solution. It's basically one point on the system, and this is the homogeneous solution. That's an H, not an N. So that's nothing new, it's just a way to write it and to think about that, okay? So it's nothing new except that XP and XH, if you ever see that, that's what they are talking about. Now, let's talk about independence and dependence. The column vectors are dependent. Do you remember which type of solution dependent is? So if it has infinitely many solutions, it's dependent, because one depends on the other. If there are infinitely many solutions. And independent if one solution, and that actual solution is just zeros. So this is an exact question we would have seen in Chapter 1, but the only ones we solved in Chapter 1 were the ones that were obviously a multiple of each other, then you'd say it's dependent, or a 2 by 2, because we could solve a 2 by 2 system. And now this has 4 in it, it doesn't matter the size, because we can row reduce to actually solve the system. So when we were deciding whether vectors were independent or dependent, you would set up the system to solve. So a linear combination, like, say, A plus B plus C, and we set it equal to 0, and we solve and see if there's more than one possible solution. And some of you went wrong on the test in this way, getting messed up with it because it was a 3 by 3, and what you needed to do was just look and see if any of them were parallel or multiple of each other, and then automatically dependent. No need to do anything. Are any of these a multiple of each other? Not that we can see, no. They're not. So it's not as easy as just saying that. So now we actually have to do something to check. So this is just a system. It's a system of equations. 2, 3, 1, 4, minus 1, 1, 2, 3, 4, 0, minus 1, 1. And we would row reduce it. And here's what we get. So, is it dependent or independent? Does it have one solution or infinitely many? Here's your variables. I called them A, B, C here. We could have called them X1, X2, X3. Doesn't matter. Does A have a lead 1? Does B have a lead 1? Does C have a lead 1? Is there any free variables? Any letters left to be free? No. A row of zeros doesn't mean it's free. It just, the lead ones tell us that. So here A has to be 0, B has to be 0, and C has to be 0, so it's independent. Okay. So what if it were dependent. What's that look like? This is the last question. I didn't have to go back to span, but I think it's important because lots of people didn't do that very well on the test on that question. And this is the same thing, except now we can actually do a row reduction to solve it. So for A, to find the general span, you set up the system with a general vector as the answer, because you're seeing what types of vectors you can get. So you would set up the system to with just a general vector like x, y, z. And just like those other ones where we were solving it at the end of the last section with the A, B, C, the same idea. But you're actually going to write out the type of vectors or write out the solution once we solve it. So if we will reduce this, make that a 1. And I'm just going to do it quickly so that divided by 2, and then we're going to make these into zeros. So row 2, that's a -2, so we need a +2. And row 3, that's a -4, so we need a +4. Okay. Now this is where it starts getting tricky. So I just did the steps and you can try them. But here you're going to either divide by 5 or switch. So obviously switching would be better in this case. Row 2 switch with row 3. We're also going to have to change the signs here. I'm going to change the signs. So here, if we change the signs, it might be minus z minus 2x. Change both. I feel like these are supposed to be the same number. I might have messed up because I'm trying to go fast. Because I want one of these to cancel. Where did I make my mistake? Should that 1 be a 5? Or? All right. Yeah, I can just write the answer out here, just a sec.
How do you know it?
Because it's not doing what I wanted it to do when I made up the question. So I don't know if it's a mistake or if I wrote the question wrong, what I did. You don't see mistake? Did you do the steps, or? No one sees a mistake, yeah. So, I mean, what we would do next is, see, we're going to have a lead one everywhere. So this is what, so it's fine. Let's say we have a lead one everywhere, okay? So we're going to get rid of this, row 3. So minus 5, row 2 plus row 3. And here will be 0, 0. Minus 5 is 5. 5 minus 1 is 4. And then minus 5 times this, plus row 3 will give me 5z plus 10x plus x plus y. So this will be 5z plus 11x plus y. Okay, kind of crazy. This we would then make a 1, and that works, right? So it has the solution, always. So that's fine. So if we have a span that we can get a lead 1 for everything, okay, it doesn't matter what's here, here, and here. It doesn't matter what's in these spots. We've got a lead 1, and we can make zeros. Using the lead 1, we can make zeros. So it doesn't matter what numbers are up there. And it actually doesn't matter what's here, does it? Because if this is a 0, that's okay. If it's anything, it's okay. It's still a solution. It could be a 0, it could be a 1, 2, 3, it could be anything, and it still has a solution. So this always has a solution. And we say unique, meaning not infinitely many solutions. It has a solution. That actually means that the span of those vectors is all of our 3, because we can get any answer. It doesn't matter what we put over here, we would be able to find the answer. Okay? So, if that's the case, this is a row reduction. For part B to be independent or dependent, what would it be? These would all be zeros, but the row reduction would still be the same. We could still get these. It doesn't matter what's here, except this side is all zeros. So we'll have x equals 0, y equals 0, z equals 0. That's independent. I meant for these to be dependent. That's why I was not happy with my answer. And we're out of time, but I just want to say, like, say the span, let's make one up. Okay, say we wanted to find the span of, we'll make one up that works, and then you can try it with row reduction later and see. Actually, I can probably write it down. So, like, let's say that x plus y is z. Minus 1, 1, 0. Do you agree with those? So how I made them, I put an x and a y, and then I added them up to get the z. 1 plus 2 is 3, right? So the span of this, when you go to solve it, you have an x and a y, and this is x plus y. Okay? Now this is what I was talking about earlier. When I make up questions, then I just work from the answer I want and get the question. I must have messed something up when I made the question last time. But basically, here it is. Our condition, when you do your row reduction, what you would end up having is something like this. Okay, and it doesn't matter what's there. Where did the Z come from?
Okay.
Yeah, when we row reduced, it would have had a Z in it to start. Right, so you would have set it up to row reduce with X, Y, Z on the other side, okay? This is just the answer that you would end up getting. I'm giving you the answer before you start. The question wouldn't have the answer there. But if you row reduce, you would have ended up with this, okay? So this is what I wanted to happen last time. So you end up with zeros at the bottom and then something over here. And for this to have a solution, just like we were doing before, for it to have a solution, it would have infinitely many solutions because it doesn't have a lead one. Z minus X minus Y would have to equal 0. That would have to be a row of zeros. That means that Z would have to equal X plus Y. If we solve for Z? Yeah. And so then that's your condition for these. We didn't end up with a lead one here, so it didn't span all of our 3. It has a condition for it to even work, and that condition says that Z has to be X plus Y. So in our original X plus Y plus Z, it's saying that Z has to be X plus Y. So the span of those vectors is X, Y, X plus Y. So whatever you get at the bottom when you row reduce and you're looking for the span, whatever you get at the bottom is your condition. That has to be a whole row of zeros, so whatever's here will tell you what type of vectors. And you just solve for one of the letters and plug it into the original X, Y, Z. That's it in all that we have in 2.6. So there's lots of practice questions to do and the test. So you can jump right to the test if you wanted to and try to look back at the questions, or you could try to do the questions, remembering on the final exam you can't look at anything.